Hello, and welcome to another Chi-Prime video, where we again solve a problem to prepare for the GMAT. As usual, I'll give you a second to pause the video to solve the problem if you'd like by yourself, and then we'll proceed to solve it together. All right, so let's begin. Here we're given that a cube has a vertex A, and a sphere with a cube of side S has a vertex A, and a sphere with the same radius S and a center at A cuts into the cube, and we're asked to find out what the volume is that's left of the cube, right? So just as an aid, visual aid to understanding how this looks, let's say we look at the cube from one side, right? So then the sphere cuts it this way. Pardon me, this is supposed to be a spherical surface cutting through the cube. Then if you look at it from the other side, where A is on the left, right? You see the surface of the sphere cutting it this way. And if you look at it from the top here, where A again is this corner, you'll see the cube, the sphere cutting it this way. So in other words, essentially you have 1/8 of the sphere intersecting the cube, cutting through the cube, right? So cutting through the cube. A good way to visualize this would be if you consider a sphere as a lemon, then an octant of that lemon typically would represent what the volume of interest here, right? So the volume of the sphere intersecting the volume of the cube, if we call S the sphere and C the cube, the intersection volume would be 1/8 the volume of the sphere, right? So that's the volume of the sphere is given by 4/3 times pi times the radius of the cube of the sphere, which is S. So S cubed. 1/8 of 4/3 times pi times S cubed. That's the volume of the intersection. So that would be the volume of the shaded volume here in these figures, representing the top and the side views. All right, so that would be, I'm sorry, 4 times 4 was twice in this, so pi S cubed over 6 would be the volume of the intersection. We know the volume of the cube, equals S cubed of side S is S cubed cubic units. So the volume that remains, volume of the cube outside the sphere S is equal to S cubed minus pi S cubed over 6, or S cubed times 1 minus pi over 6. That's the volume we want, and that is option A. Thank you for watching. Just for clarity, we might want to also provide another illustration. This is the cube. This is point A. And the sphere is something like that. As closely as we're able to draw it in 3 dimensions. So there you go.